So for today, it's a review plus adding on and making it a little more complicated. So yesterday, we made this a little more complicated. Notice we went away from inverse trig yesterday. If this had been an inverse trig question, it would have looked like this. They are very similar, but what's the difference? Well, inverse trig has all these restrictions. This one's got two answers. This one's got only one answer because I've told you every inverse trig problem that you're going to see, it's only going to have one answer. All right. So today, we're setting aside inverse trig again for more of these. And what did I do yesterday that made them more complicated? How would this problem look different yesterday when they stepped up a notch? Yes?
We nested them into other functions.
That's true. We had nested ones. That is true. But what I'm talking about is this exact problem would have had another number in it, which would have made it more complicated. You remember?
Yeah, you would have put like a 2 in between, or like right after sine.
Yes, so sine of 2 theta. And you might be thinking, isn't that something off the sheet? You don't want to think of it that way, because then you'd have to replace this with one of those things off the sheet, and that would not make it any easier. Okay, so the way this was done yesterday is we said, you know what? Make it easier. Just call it sine of u equals 1/2 and get those two answers like you always did in circle trig. So I'd like you to do that right now. Find me the two answers. There's two quadrants, ASTC. This is not inverse trig, so we're not doing those restrictions about where this can only be here and that can only be there. Find me the two answers for this. And at the end, it'll be like u equals, pi over 3, and u equals 2 pi over 3. So that's not right. So what we're really doing is we're letting u equal 2 theta so that we can make our problem easier for now. Did you figure out that sine was positive, so it couldn't be here and it couldn't be there? And did you realize that sine is opposite over hypotenuse? And 1, 2 square root of 3. This one very similar, but not exactly the same. 1, 2 negative square root of 3. Then, my two answers for u was equal to this angle right here, which is pi over 6. And u is equal to a whole bunch of pi over 6's all the way to there. 5 pi over 6. Raise your hand if you had that one right. Okay, awesome. Then, we had to go back and say, but it's not really u. U is really 2 theta. So then I go 2 theta and 2 theta. And then how did you solve it at the end? Well, you just had to get the 2 off of there. So you multiply everything by 2. No. What do you do to get the 2 off of there? Say it. Divide by 2. Or multiply by 1/2. That would have been a good answer. And theta is pi over 12. And 5 pi over 12. But the problem is, the thing I didn't talk to you about yet, because that was hard enough. We were just learning how to do inverse trig, and then all of a sudden I switched to this. Because why? Because we're solving equations. And inverse trig problems are a lot of times problems to solve. So when you're solving this original problem, which would have been sine of 2 theta equaled 1/2, you were trying to find theta. You were solving for theta. Well, there's a lot of different ways you can solve for theta. So theta equaled this, and theta equaled that. But what if I said, oh, by the way, I want all the answers that would happen between 0 and 2 pi. And that's the way they say it. And that means if you happen to weirdly get the answer of 0, you'd say 0 and not 2 pi. Do you get 0 and 2 pi are pretty much the same thing when you're going around the unit circle? 0 and 2 pi are in the same spot. So they say it can be equal to 0, but it can't be equal to 2 pi because that would be a repeat of 0. Okay, so the answer is between 0 and 2 pi. The problem with this is that if you stretched out a whole bunch of pi over 12s, 1 pi over 12, here's 0 right here. And here's 2 pi right here. 1 pi over 12. This would be 2 pi over 12. 3, 4, 5, 6 pi over 12. 7, 8, 9, 10, 11, and this one, of course, is 12 pi over 12. We have given two answers that are right here, and 5 pi over 12, which is right here. And wait, isn't this a wave? If this is a wave that's gonna basically have to go through a few more times, do you get there's a couple more answers between 0 and 2 pi? All right, another way to think of this is this. If I just said sine of theta equal to half, I want to go back to what that really looks like on a graph. You know sine looks like this, right? And this comes back to, do you really understand that you're really graphing y equals sine and y equals 1/2? And y equals 1/2 would be like this. Do you get there's basically an infinite number of answers to this question? Sine of theta equals 1/2. Look, that's an answer. That's an answer. That's an answer. That's an answer. And it just keeps going forever. So this two answers that we have here are just kind of arbitrarily the first two answers that you would hit. There's actually more answers. All right, so that's for regular sine of theta equals 1/2. There's actually unlimited answers. We've usually just limited that to between 0 and 2 pi. But as soon as you put a 2 here, I'm only explaining this for the people that want to know why this works, okay? Otherwise, if you just like, tell me the simple thing to do and I'll do it, I'll get to that. But the reason when I put a 2 here, the reason that this thing changes is, do you get that the red wave there does not get twice as wide, it's on the inside, it gets half as wide. That means that my wave finishes up twice as fast. The sine wave used to finish up right there, but now it's going to finish up. Hold on. But now it's going to finish up there. And it'll finish again there. And it'll finish again there. And it'll finish again there. Basically, my wave got a lot tighter. So instead of just those 4 black arrows, all of a sudden I'd have all of these, let's make them green arrows. I'd have 1, 2, 3 answers, 4, 5, 6, 7, 8. I'd have tons of answers because of this 2. All right, so what I'm trying to say is you got a lot of answers. And I only gave 2 of them. So now I have to teach you how to find the rest of them. Okay, so on this example problem, we had pi over 12 and 5 pi over 12. How far apart were they? Yes. Keep going. 4 pi over 12. That's how far apart these were. I wish it was as simple as being able to just say, we'll just keep adding 4 pi over 12 over and over and over again. But see, the problem is, if you look back at these, it's like you get 2 answers and then you have to wait quite a while. And then you get two more answers, and then you have to wait quite a while. And you get two more answers. So it's not like they're always exactly the same distance apart. So what you can do, though, is say, it's going to repeat based on its period. Where there was an answer and there's another answer, it repeats based on how long its period is. So if this hadn't been stretched, I could simply add 2 pi to it. Do you get that I could just add 2 pi to it and I get another answer? Okay, but what's its period actually? Well, its period was original problem. Its period would have been 2 pi, but then there's this 2 here. And so its period was 2 pi, but now you go 2 pi over 2, and its period is now pi. You're right. So then that means I have to add pi to my answers. Not 2 pi, but pi. So I'm just going to go like this, 2 pi over 2. So you see this little, when we multiplied by 2 on the bottom, that was really, we were multiplying by 1/2. We'd also have to do that to the 2 pi. And then these will cancel, and that tells me, okay, just take pi over 12 and add pi to it to get the next answer. Now, pi over 12 plus pi, I would prefer to add 12 pi over 12. Because 12 pi over 12 is the same as pi, but it'll add a lot nicer to my 1 pi over 12. 1 pi over 12 plus 12 pi over 12 equals 13 pi over 12. That's my next answer. And I got to just make sure that I don't go over 2 pi. What is pi really? It's 12 pi over 12. I'm going to add that to my 5 pi over 12. And now I have 17 pi over 12. Now, I'm going to give you a guideline to know how far to keep going. Should I just keep on going? Well, normal problem. Do you remember how they had 2 answers? Just what's your gut? When I put a 2 here, how many answers are they going to have now? 4 answers. What if I put a 6 here? 6 times as many answers as they used to have. They used to have 2 answers. Now it's got 6 times as many answers. So it could have 12 answers. On a test, we probably wouldn't do that because, frankly, we wouldn't want to check all 12 of those answers. It'd be a pain. So realistically, you almost always see that we'll put a 2 here or a 3 there. The worst is a 3, probably, because then we got to go 3 times as many answers as normal. Normal is 2. So if I gave you this, cosine of 3 theta is equal to negative square root of 3 over 2, you could go, crap, it's going to have 3 times as many answers as normal. And normally it'd have 2 answers. So that means there's 6 answers. Do you remember me telling you at the beginning of the year that this class was going to get hard enough, so sometimes you'd have 6 answers in a question? You've reached that day. Okay, so there's 6 answers for a hard question on this next test. All right, so let's attack this one, but first I have a question. Yes?
Is there also an answer at 9 pi over 12? Because it, why does, you know how you have like 12 pi over 12 each time? Why does that not apply to when you change it from pi to 5 pi over 12? That applies at once, but not there.
Okay. Let's look at our wave again for a second. So his answer was basically, why can't you just add the same thing over and over again? So there's sine. I know it's not beautiful, but it's good enough. And let's say that we want sine to be 3 over 4, 3/4. Well, that isn't 1.0. 1.0 would be like here. And that'd be really easy. We would just add 2 pi to get each answer. Do you get what I mean? I just saw over 2 pi each time. Okay, but that's if y was equal to 1. So let's draw this green line here through at 3/4. You get how these answers are, it's where the lines cross, right? So these answers right here are pretty close to each other. Those are not 2 pi apart from each other. But if I go over 2 pi, I can always pick up another answer. And I can go over 2 pi, and I can always pick up another answer. See what I mean? And 2 pi isn't magic, it's just the period of the starting one. Okay, so these first two are not 2 pi apart because of how the wave looks. And this isn't as easy to figure out. That's why we have to do all of that math at the beginning to find those first two answers. But after I find the first two answers, the other ones, you just have to add the period to it. All right, that's a lot. And that's the main thing for today. So let's see if you caught it. Let's go do a fairly simple one. All right, it's actually that one we were just talking about, except I don't want to start with a triple. We'll double it. Cosine of 2 theta is equal to negative root 3 over 2. First thing you need to do is make the problem easier right off the bat. Oscar, what are you going to swap out and say, nope, too complicated, I'm going to replace this with that?
It'll be
Let u equal 2 theta. So your new problem would read what?
cosine of u equals negative square root of 3 over 2.
Excellent. And then you just made it into a circle trade question. Chapter 12. The one that I said would be the most important because it keeps coming back. Okay, so find your two answers for that. But remember that at the end, there's this, which tells you that there's actually going to be 4 answers. All right, so I'm hoping that you knew cosine was negative. So we're going to cross off this one. We're going to cross off this one. Cosine, adjacent, hypotenuse. That must be a 1. This angle's the central angle, the key angle, so that's the one that tells me my answer. Kind of. That one is a 30, because it's across from the 1. It's a 30, also known as a pi over 6, and that means this is actually 5 pi over 6. Raise your hand if you knew 5 pi over 6 was part of your answer. Okay, good. And then the other one is down here, and no need to replicate all of that triangle making. If it's 5 pi over 6, it's also 7 pi over 6. All right, so then those are my two answers. U equals 5 pi over 6. And u equals 7 pi over 6. Now, right now, remember, we still haven't swapped out our 2 theta yet. So listen, watch, because I know some of you went ahead of me, which is totally cool. Glad you did. Write plus 2 pi right here, because at that moment, we were still assuming that this was normal cosine, where you would have a 2 pi. That's what you would do to get your next answers, because you know we need 4 answers, right? Okay, now my next step is, this answer is one of my answers. Then I add 2 pi to it to get another answer. And then this answer is going to be one of my answers. And then I'll add 2 pi to it to get another answer. But do I really want to add 2 pi? No. So here's why. Because u equaled 2 theta, so I think most of you knew to go through and put a 2 theta here, right? And then, you remember how to get rid of that 2 in the front, you would then go through and multiply or by 1/2. Guess what else has to be multiplied by 1/2? Yes, the 2 pi has to be multiplied by 1/2. So here are my answers. The first one's right there. And it is 5 pi over 12. The second one, I'm going to add 2 pi over 2, which does cancel and just becomes pi. So my next answer is 5 pi over 12 plus pi. But do you get, I'm going to be smarter than that and say 12 pi over 12? That's the same thing as pi. But now it's got a common denominator. So my second answer, 17 pi over 12. Next answer, this one. And that was 7 pi over 12. And then my last answer, all of that, 7 pi over 12 plus 2 pi over 2. But that's really should be 12 pi over 12, because I'm just trying to add pi to it, bringing me to a total of 19 pi over 12. Now, one more hint. If I added one more period onto these things, do you get it would go over 2 pi? That's another way to tell you're done. First off, I've got 4 answers, and that's what I was looking for. But if I added another pi to this, do you get it's going to go over 2 pi? And the limit is always going to be the answers between 0 and 2 pi. All right, so there's your 4 answers. All right, I need to give you one more for you to do from the top. And then I think you'll have it. I want to start using some slides here. This is just a reminder that, yeah, you're going to have to know stuff off of the identities. Let's just take 2 seconds and remind you of a few. What could you replace secant with? Yes? Just plain secant. It's the sister function of what? Secant goes with cosine. It's okay, it's been a while. And cosecant, what's that one go with? So that's 1 over sine. Those kinds of things, I know it's been a while. There's going to be a sheet full of them that you may need to use at some point. So let's just do 2 more. What could you replace cotangent with?
Tangent.
You can't just say cotangent is tangent.
1 over tangent.
1 over tangent. Or, all right, let's just do 1 over tangent first, because that wasn't wrong. But alternately, you could have said cosine over sine. And tangent is sine over cosine. Those are just some of those identities that you need to know. This is not how you would solve this one. I don't want to take the time to do that right now. My back is killing me, so I'm going to get done with this lesson here. Again, I could find these things on the sheet. As soon as I see cosine of 2x, I'm going to go running for the sheet and go, what the heck is that? I got 3 choices of cosine of 2 theta. It's called a double angle. You'd find it on the sheet. You could replace it with stuff off the sheet. All right, so then we just did problems like this, which we just did that one, except it had a negative in it. Otherwise, that's the one we just did. All right, so here's another one, and it's just a little bit different because that looks complicated. Well, lucky for you, you're going to just replace it with a u. Okay? So go ahead and give that one a try. Completely ignore this for now, please. Just trying to do example 1 there. Okay, just see if you got this far correctly. I'm going to let you equal x over 2. So now my problem becomes sine of u equals 1/2. Now, wouldn't there normally be two answers to this? There will be. Don't assume that then there's only going to be one answer, but maybe since we divided this by 2, maybe there'll be less answers than before. But we'll deal with that later. All right. So if I were going to do this sine equals 1/2, then all students take calc. Gives me a clue that sine is positive in the top two. So this is out and this is out. Then sine is opposite over hypotenuse, square root of 3. Pi over 6, that's an easy one. And I can do this one in my head, 5 pi over 6. Raise your hand if you knew that those were part of the answer. Good. So then u equals two things, pi over 6, and u equals 5 pi over 6. But there's more. Because why? Because right now we're still operating under the assumption that it was just normal sine. See, like we took out the stretch or the shrink. So we add 2 pi here. Raise your hand if you remembered to add 2 pi right there. Okay, because this is critical. Now we're going to replace that u with what we said it was. U is x over 2 because the original problem was that. So we're putting x over 2 right here. And now to solve that, I'm going to multiply everything through by a 2. 2 here, and 2 here, and 2 there. 2 here, 2 here, and 2 here. Of course, that's not 22. That's 2 times 2. Okay, so now that cancels that cancels that, and my answers are, this is where you got to be careful. The first answer is just this one, 2 pi over 6. I could leave that as 2 pi over 6. I think it might make your answers flow nicer. I know, we could reduce it, maybe later. And then we got to do this answer where we add 2 times 2 is 4 pi to that. So my next answer is 2 pi over 6 plus 4 pi. But wouldn't it be nice if that was in sixths? So then I'm going to make it in sixth. I'd have to times the top and the bottom by 6. Bottom is a 1. So now I got 24 plus the 2 is 26 pi over 6. Now, here's my first answer. 2 pi over 6. Is that less than 2 pi? How about 26 pi over 6? Let's reduce it. Would you agree that that's the same as 23 pi over, I'm taking half of it, so then this is 23 pi over 3. Oh, help me, thank you, 13 pi over 3. Is 13 pi over 3 less than 2 pi? No. If only answers are supposed to be between 0 and 2 pi, this one is. That one's not. It's too big. That means this is too big. Gotta throw it out. Yes?
But like, since the period was like stretched because it's a stretch of 2, then wouldn't the period become 4 pi, which means if it's less than 4 pi, it's stretched?
Nope. The original rules apply. It says it's gotta be between 0 and 2 pi. Your answers you give have to be between 0 and 2 pi. All right. So our first answer, 2 pi over 6, that's in the range. It's between 0 and 2 pi. The next answer is right here. Maybe even that one's too big. 10 pi over 6 is my next answer. 10 pi over 6. Isn't that the same as 5 pi over 3? So is that bigger than 2 pi? 6 pi over 3, that would have been 2 pi. So we're a little less than 2 pi, so that one's still safe. You going to want to add anything to it, though? No. So there's my two answers. That's still less than 2 pi. So is that. don't have to worry about finding any more. Yes?
Don't you have to add, like that 5 pi over 6 with that 2 pi and then what?
Okay, so our first answer is just this in the black circle right here, which is 5 pi over 6, but times 2. The next answer we would get would add the 2 pi to it. The adding 2 pi only happens to try to generate more answers. All right, so only the original 2 answers worked. This whole adding 2 pi thing was just a huge waste of time because it ended up making answers that were too big. Wouldn't that happen every time? Not every time, but every time that you had a fraction right here, then you're going to end up having to try to add something bigger than 2 pi, which obviously means your answer will be too big. All right, 2 more things I have to get through. And there's a lot of different ways we can write equations. Sine squared of theta is equal to 3/4. If I'm solving equations, this would mean the same exact thing as if I had said sine of theta quantity squared equals 3/4. Do you get that the blue one and the black one mean the same thing? Okay, how do you get the squared off of there? Square root. So I go square root and square root. And only some of you are going to remember that this is actually the absolute value of sine is equal to square root of 3 over the square root of 4. And, ooh, I happen to know the square root of 4. Absolute value of sine is square root of 3 over 2. And the fact that the absolute value means you'd have 2 answers. Sine of theta equals root 3 over 2. And sine of theta equals negative root 3 over 2. And doesn't that look like that's going to have 2 answers? And that's going to have 2 answers. There's 4 answers to this one. Yes?
How do you know when you should put like the square root thing in absolute values like that?
When you square root a variable, do you see how there was a variable in there? If you ever take a square root of a variable, so here is the first time it ever happened to you. X squared equaled 16. And your teacher probably just glossed over it and went like this, and then said x equals plus and minus 4. And then half the class thought that there was no absolute values, first of all, but there were. And the other half the kids thought that there's 2 square roots of 16, but there's not. I really wish we'd spend more time being careful about this. The absolute value of x is what happens when you square root a variable. And the square root of 16 is just 4. Then you can break it into 2 things. X equals 4, x equals negative 4. So it's that same exact process happening, except now you're in trig. Okay, so let's see if you can handle one of those. Cosine squared of theta is equal to 1/4. Solve. Now, what we just did today is tricky stuff. You need to really have a good example of it, and you need to practice it. Right now, it's just like you watched somebody do something really complicated. I don't know, equate it to sports, it'd be like somebody running a zone defense for the first time. You've never done it before. It's going to take a while before you're good at it. But you got to practice it. You can't just talk about it. So please, when you go home tonight, do some homework. Practice some of these. Okay, I'm going to square root both sides. Is that what you did? Absolute value of cosine. And, ooh, this works out nice. Square root of 1 is 1. And the square root of 4 is 2. Then I break it into 2 problems. Cosine of theta equals 1/2. And cosine of theta equals negative 1/2. And doesn't this have two answers using circle trig? And doesn't this have two answers using circle trig? Yup. You know, cosine's positive. All students take cosine's positive over here, so I get two answers for this one. I love that I can just draw a couple triangles and you'd know, oh yeah, I just got to set my angles up in those triangles. And then over here, cosine's negative. Oh, students take cosine's negative, so it can't be here and it can't be here. And if it's negative, it'll have to be here and then there. So I got four answers. Is this the kind where you got to add 2 pi? No, that's not that kind. Would you please get those four answers? And there's a person, rows 1 and 2, you can compare with each other, rows 3 and 4, compare with each other, get the four answers and see what you think they are. Just put them in order from smallest to biggest. It's much easier to show them that, the four answers. Remember, you're across from the root 3, so this is a 60-degree angle. So what is it really? Pi over 3. And so this one will be 2 pi over 3's. This one would be 4 pi over 3's. And this one would be 5 pi over 3. So you have 1 pi over 2, 1 pi over 3, 2 pi over 3. 4 pi over 3 and 5 pi over 3. Raise your hand if you had that one right. Okay, awesome. So that's another kind of solving that you have to do. And last but not least, let's keep it super simple. Let's say it was 2 sine equals cosine. And let's say that's, yeah, just that. Okay, if I had to solve this, my best tip for you is to get it all down to one function. And if I divided both sides by cosine, do you agree that this would cancel, but that does not mean it disappears? What does it turn into? 1. And what is sine over cosine? Tangent. Look at that. You think you could solve it from there? Divide both sides by 2, and okay, it's not one I'm used to, but I could do that. Like, it'd be nicer if this just came out to 1. In fact, I'm going to cheat. I can do that. It's my class. I'm going to say that's just a 1. So then this is just a 1. And so tangent equals 1. We've done that one before. That's pretty easy, isn't it? 1 over 1. And then tangent is positive. All students take calc. So it can't be here and it can't be here. And it'd be here. And TOA is opposite over adjacent 1, 1. And oh yeah, the 1, 1 root 2 triangle. So then this must be a 45, also known as a pi over 4. And then a bunch of pi over 4s. Say it if you know the last one. 5 pi over 4. So pi over 4 and 5 pi over 4. All right, so if I had to sum up the biggest thing for today, it was questions like this. Let's say you have sine, except that we'd have a 3 now here. And I could even put, I'm going to just make it even a little trickier. Plus 1. 3 theta plus 1 equals 1/2. And then you'd go, man, that's too complicated. And you're right. And so you'd replace it with a what? A u. And then you could solve this one. And by now we've done this one so many times, you're probably like, come on, Mr. Server, we've done that one so many times. It's pi over 6. And then if you're really smart, you'd be like, and I know it happens here and this quadrant. They're both. So pi over 6 and 5 pi over 6. That's the two answers. U is pi over 6. And u is 5 pi over 6. If you're awesome at this, I could see you getting that fast. And then you replace the u's with 3 theta plus 1. And then you just have to subtract 1, which is going to be a bit of a pain, I know. And then you're going to have to multiply everything by 1/3. And then you could get your answers that way. But wait, what was the extra complication? We needed to keep our answers between 0 and 2 pi. All right, so if we were going to do that, I would not have done this part if we were going to ask you for those between 0 and 2 pi answers. If we did that, it'd be down to this. And then you got to remember that to get the next answer after this one, you're going to add 2 pi. But remember, I don't have to add 2 pi. I get the first answer just by solving this. And just by solving that. Those are my first answers. To get the next ones, I'd add 2 pi. But since there's a times 3 here, once I go through and multiply everything by 1/3, this also gets multiplied by 1/3. And so my first answer would have been pi over 18. Second answer, 5 pi over 18. Third answer, I'd take this one and add 2 pi over 3 to it. And for my fourth answer, I would add 2 pi over 3 again. And this would be brutal because, do you remember if there's a 3 there, you'd actually have 6 answers? So where are you going to get the last 2? You would take this answer and add another 2 pi over 3 to it. So it'll go up another 2 pi over 3. So add another 2 pi over 3 to it, and add another 2 pi over 3 to this. And all of a sudden, you've got all 6 answers. And I know that's a lot. And I'm just trying to summarize to the end of the hour. I know that's a lot. You signed up for an honors class. Does this feel honors level? Probably should. You can do it. And it won't stick it unless you practice. So, there's your assignment. Notice, they're not going to be beastly. And we can't make them as hard as what I just talked about. I was just trying to show you like the extent of how crazy it could get. But if you can just go back to solving something like this for today, like right now, and get the answer. How could you tell if you were right? Go check the answer key. That would be so smart. Okay, so go do a few of these and see if you can get them. But what if it's cotangent? Well, then write it out and then flip this over and you'll have just changed this to a tangent question. And then it won't be so scary anymore. All right, that's all I have for the video for today.